So hi and good morning and good evening everyone. So welcome to MuleSoft Mysore Meetup group. So today we are at the topic automating MuleSoft deployment with GitHub Actions. So this is the part 1 of the two block series. Okay. Uh, can you move to the next slide? So we are the organizer. We three are the organizers, and both all three of us are MuleSoft ambassadors. And so I myself I am working in Millennium, and I'm an integration developer. Girdhar is working in Hasdin as a technical architect, and Priya she is from LTM entry and working as a senior software specialist. Okay, so you can move to the next slide. So today we have speaker Senia. She's from Canada, and basically I would like to thank her since it is 1 a.m. and at her end, and she's taking the meetup for us. So thanks a lot, and the floor is yours.
Thank you. So, first of all, I want to express my gratitude to Shubham for inviting me to take part in this meetup group. Even though it's 1 a.m. at night for me. My name is Ksenia Tarantsova, and I'm a senior software engineer at Bits and Glass. I have more than 5 years of experience in MuleSoft integration and IT. I hold 5 certificates from MuleSoft, and I also actively contribute to MuleSoft community as a MuleSoft mentor. And most of my contributions involve writing articles for another integration blog. And also this year, I was honored to be chosen for the amazing Top MuleSoft Mentor program. So yeah, let's start our agenda for today. It'll include overview of CI/CD. We will quickly talk about what CI/CD is and why is it so beneficial to have automation. For the application, we will talk about GitHub Actions and the main components it has, especially the core component is a GitHub Actions workflow. Then you will see a demo about how to create a workflow files from scratch. And at the end, we will be going over benefits of integrating MuleSoft with GitHub Actions. And at the end, a Q&A session. So your question, my answers. So let's start with a quick overview of CI/CD. What is CI/CD? CI/CD is a set of principles and practices designed to help development teams deliver code changes reliably and frequently. And it also involves the ongoing automation and monitoring of the entire application lifecycle. And it's from integration and testing to delivery and deployment. And this all is actually a huge part of MuleSoft's API lifecycle. And here it says that CI/CD is a set of practices, but actually there are two practices. First is the CI, which stands for continuous integration, and another is CD, which stands for continuous delivery or continuous deployment. So what's the difference between CI and CD? CI focuses on moving development work from isolated silos to the entire development team. And that means also that CI is a development process, ensures regular testing and merging of code changes. So it also requires development team to frequently integrate their code changes into the shared repository. And as the primary goal of the CI is to establish a consistent, ongoing method for automatically testing and building our application. That all you can see on the picture, these 3 pillars of CI, is basically the code changes, building, and testing of our application. CD is an extension of CI and is mainly focused on delivering development work to the end user. And CD makes releases regular and predictable events for developers and seamless as well for end users. And the goal of CD as well is to maintain code in a deployable state at all times. This enables updates to go live with minimal issues. So CI/CD pipeline. The central to the CI/CD process is the CI/CD pipeline. CI/CD pipeline serves as an automated workflow that builds, tests, and deploys code changes. So every change to your code just works, build, test itself, deploys automatically, and this is what the CI/CD pipeline does. And why this automation is so beneficial for us as developers and for the whole development team is, first of all, because of the software quality. It significantly improves software quality by reducing human errors through consistent processes, ensures early detection of bugs, thorough application testing. It also increases release cycle speed. So automation speeds up the release process, provides developers immediate feedback on their changes. And third, it's a reduction of manual intervention. This reduction of manual intervention leads to minimizes human errors, increasing productivity, efficiency, and reliability to our code. So GitHub Actions. What GitHub Actions is, and let's explore together this tool. GitHub Action is a powerful automation tool built into GitHub. And so with GitHub Actions, it's easier than ever to integrate CI/CD directly into your workflow right from your repository. As this platform resides right under your repository, under the tab Actions of your repository, to be precise. So, and GitHub Actions is only are available at no cost for public repositories. So for everyone who will be inspired after this meetup to learn more, can do it with no cost and no trial periods. Just keep your visibility of your repository as public. And for sure, for private repositories, there is a limit to the free monthly usage. So be mindful with that. GitHub Actions features. So what makes GitHub Actions such a powerful tool for CI/CD? And first of all, it's an intuitive YAML syntax. We use simple, here human-readable YAML files, and this ease of use makes designing, maintaining, understanding the automation processes really a seamless experience. Also, GitHub Actions has range of pre-built actions. We can leverage a vast library of pre-built actions from GitHub Marketplace. So need to set up a build, run tests, deploy applications. So there is likely already an action for that. Another feature is that we have a familiar GitHub interface. It's one of the, I would say, biggest advantages. We work within the well-known GitHub interface, and this, of course, ensures smooth transition and seamless integration with our existing GitHub workflow and tools. The last but not least, of course, feature is the scalability. GitHub Actions offers great flexibility. We can execute our pipeline on GitHub hosted runners for convenience, or set up self-hosted runners for the greater control, customization. And so by embracing this combination of features, organizations can really expedite API delivery and meet the evolving demands of modern software development confidently. And now it's time to talk about the components of GitHub Actions. And the core component of it is the GitHub Action workflow. So GitHub Actions workflow is a fundamental part of GitHub Actions. And each workflow is actually each workflow described within the YAML file, but it is also as a customizable automated process we describe within that file, which defined within the GitHub repository. And GitHub Action workflow includes two components. It's jobs and steps. Jobs is independent tasks that run as part of the workflow, and steps is an individual commands or actions within each job. And so how does it look from a high-level view? It is like that. So here we have a code repository. And then for the code repository, we create its own workflow. But every repository can have multiple workflows you can use for different purposes. And then every workflow consists of the jobs, and every job consists of steps that describe the automation process. So that's the structure of it. Let's dive deeply to each of the components. So workflow is, as we already could understand from the previous slide, is the overall structure that defines the automation process. Workflow is actually like our CI/CD pipeline. Workflow is initiated by specific events. The workflows are triggered by events such as code pushes, pull requests, schedule times. It could be manual run, and so on. Workflow contain one or more jobs. So workflow can have multiple jobs that define the tasks to be performed. And obviously, workflow is linked to GitHub repository. So each workflow is associated with a specific repository where it is defined in YAML file. Jobs. Jobs are individual units of work within a workflow. So it's a main part of the workflow. Job define a runner, which serves as the execution environment. So this is the environment where the job will execute. Runners can be GitHub hosted or self-hosted, providing flexibility for us. Jobs comprise one or more steps. So each job consists of multiple steps that detail the specific actions to be taken. And jobs also could be executed either concurrently or sequentially. So which gives us also flexibility depending on the dependencies and different type of configuration. So the steps are units, individual commands or actions which actually are executed as part of the job. And steps doing all the work for us within the pipeline, within the workflow, because they perform tasks such as running shell scripts or actions. Steps also can utilize custom or third-party actions. We will be seeing that in practice during the demo. And steps could be executed sequentially in the specified order. We can also add different type of conditions to the step to be skipped or to not be failed even if it fails. So there could be kind of optional steps within the workflow as well. So there are lots of flexibility for that. So in summary, just before we go to the demo, for all to have that deep understanding of each of the component, workflows, they provide high-level structure and triggered by events. Jobs define the units of work and the environment they run in. Steps, specific tasks executed within each job. So an understanding of these components is the main thing before you will start integrating GitHub Actions with your MuleSoft API. And now we are ready to see how does it look in the real life. And before the demo, I would want to quickly go over the prerequisites. We would need to start integrating MuleSoft API with GitHub Actions. And we have this, for that we need 3 pillars. It's of course, MuleSoft API project. We also need a GitHub account and any one platform account. I've already created all of that before the demo. So just for you to understand the MuleSoft API project we will be using and project to which we will be creating a pipeline is a simple CRUD API with just 2 operations. It's get and patch. Get to get the employee by ID and patch to update that employee. API is responsible to establish communication with Bamboo HR. It's a human resource management software and also known as for centralizing all employee information into a unified interface. So this is just at the end we will be checking if it was successfully deployed to the Cloud Hub and it works. We will be sending a request to that API. So if you will see that response having the fields about an employee, you will know what it is about. And the API is under the latest runtime 4.7.1 and uses Java 8 version. So this is, just overview of the architecture. Just very straightforward, send a request and receive response. All right, so this is what we will be doing now. It's our guide to create a CI/CD pipeline. We will be starting from creation and set up workflow file, define the name for the workflow, specify the trigger. Then we will define jobs, add runner, and add steps. We will be having 5 steps, get the code, set up Java, test, build, and deploy. And at the end, we will run workflow and check how does it work. So let's start. Let me stop that presentation. And so before we start, this is the, I hope you can see my screen. Okay, so this is the repo on the GitHub side I already created. So before we start, we should navigate to the Actions tab. This is, as I told during the presentation, is a primary hub to work with your CI/CD pipeline, with your GitHub Actions workflow. As you may see, here we have different type of templates to build, test, and deploy our code. So it has a bunch of templates we can use if we would need to. There is also a simple workflow we can start working on and update to our needs. And we obviously also can start manually from scratch, create a workflow. Just for the demo purpose, I want you to show how does it look like. So we need to press on that configure button. And so you will see the description of all the keywords of the file. And from that, you at least learning journey, you can start doing that. So it even has comments which describes all the keywords within the workflow. But for today, we will be doing everything by ourselves manually. So let's go to our project. To start working and to create a pipeline for the MuleSoft API, we would need to create under the root folder, we would need to create a folder.github workflows and then the name of the workflow. So let's start from that. We need to create a GitHub folder, and then under that folder we will be creating workflows folder. And under workflows folder, we need to create our YAML file. We can name it, we can give it any name as we want. Let's call it MuleSoft.cicd -cicd.yaml. Sorry, rename. Yeah, I know what was wrong. Let me delete it. We need to create a file, not a folder. So it's MuleSoft cicd.yaml. All right. So we will be starting from giving it a name. The name of the workflow, and so the name as it will appear in the Actions tab of the GitHub repository. As if this field is omitted, then it will be taken the name of the YAML file, and we will name it MuleSoft pipeline. And after that, we need to create a trigger to our actual workflow. And for that, we have a keyword on, and this on controls when the action will run. So it can either be manual trigger or pull request or release tag creation, any event within the GitHub repository. And so for the demo purpose, we will run our pipeline manually, and to allow us to run the workflow manually from the Actions tab, we will be using the event workflow dispatch. We also might need probably inputs for our workflow to accept. It's very useful, especially when you want to create a reusable one workflow, which won't have any hard-coded values. For example, within the workflow, we can define input as a deploy target. So instead of hard coding, production, whatever other environments, we can just pass it together during the workflow run. And so we can give it a name deploy target. And here is the same description actually and parts as we have in our YAML files. So it's a type, data type to our input. It'll be choice. choice. It's kind of an enum list. We define it. We can give it a description, deployment target. It's a friendly description to be shown in the UI instead of name. Then we can also define that this input will be required, and we will give them options. So as it is a demo and I created a trial account on any point platform, we will go today with a sandbox environment, but of course, if it's a real life scenario, here we need to put production, development, QA, other type of environments you have within your project. So now we are ready to, as we already have a trigger, and we know that the workflow consists of the jobs, we need to create jobs. And so jobs should have the job itself. We need to name our job. Usually, for you to know, if you have multiple jobs within your workflow, you need to configure jobs so that way, keeping in mind that every job, it doesn't know anything about what happened in the previous job. So it leads to multiple repeatable steps within different type of jobs. And it makes our workflow more complex. So for demo purpose, I decided to keep only and to create only one jobs with multiple steps. And as we will be having build and deploy within our one job, single job, we will call it build and deploy job. And we can also give it a name, build and deploy job. And we are ready now to define our runner and our execution environment on which our pipeline will be executed. So we can either use GitHub Actions, runners, or self-hosted runner. And this is all the runners, GitHub hosted runners. GitHub provides us for using them with no cost. You can even choose machine you want to run on your workflow, your pipeline. If you're more familiar, for example, with Linux or Windows or macOS, you can use any of them you want. For today's session, we will be using Ubuntu latest. And so the keyword to define the runner is runs on. And we just need to put the label, and that's all. All the work will be done by us. And now we are ready to define steps. So as I told, we will be creating 5 steps, and first of them will be get the code. Get the code, name get the code. So get the code, we need to check out our repository under the GitHub workspace, so our job can access it actually, and use our code for the next steps to test, build, and deploy. So with that step, we get for our code to the runner's machine. And every step can be can be run within the action, or we can also execute it by using shell script. For that get the code step, we can utilize GitHub Actions, GitHub Action from the GitHub Marketplace. I will show you. Actually, it is so cool. GitHub Action has this marketplace where you can find any action you want for different type of purpose you want. But of course, be mindful, because these actions, they created by different developers, and if you use these actions for your project, for the client project especially, better to check whether the action has that verified from GitHub checkmark. That means it's secured and can be used without leaking of secrets or any other things. But anytime if you want to use any other custom actions without that check mark, you can also check the code for that action to be sure it is the good one. Actually, does not have any leaking things, and you can navigate by clicking on the repo itself and see everything what the action does under the hood. Luckily for the checkout, we have an action verified by the GitHub, and we need to use a keyword, as you may see here, uses, to make the action work. And GitHub is also advised to use for each action version tag of a public repository. So we will be using the checkout version 4 to check out to our code. Yeah. So just need to put here uses, and it'll do all the work for us. The next steps will be set up Java. The same thing for that one. We also have an action for that on the GitHub Marketplace. This is the one, and we just need to define the distribution and Java version we will be using for our workflow. And also it provides us other opportunity, like to use cache, for example, to cache our dependencies. So like when we run our workflow for the first time, we can cache all the dependencies needed for the project, and the next time will take us less time for the run. And that is also a very good option and Action has. So setup Java, we will be using an action setup Java. If I'm not mistaken, it also has version 4. And this with key is like some action requires these inputs that you must set using the with keyword. And with let me go with distribution. Adapt hotspot. You may use OpenJDK, Timurin, any other distribution you want. And the Java version is 8. And we want to, of course, cache our dependencies from the project. So the next step is actually testing of our application, running unit tests. We don't have any predefined, pre-built actions for that steps. So we need to write the shell script for that. And as you may know, MuleSoft is a Maven project, and we need to use Maven commands to run unit tests. So it is Maven clean test, and also in this project, as it is connected to the Bamboo HR system, there is a credentials. So we also need to provide a secure.key. And for that, we need to, instead of like hard coding everything in this workflow file, we want it to keep private. And for that, we need to create secrets also on the GitHub side, and just pass them to our workflow. And to create such secrets, you need to navigate to the settings tab, and under the security block, secrets and variables, you need to press on the actions, and here you will be seeing the environment secrets and also repository secrets. So secrets are variables that you create in organization, repository, or repository environment. And to make secrets available to an action, we must set the secret as an input or environment variable in the workflow. And here we need to create that, to add that secrets to be encrypted and passed to our workflow. So I already created some of them, but here we will create a mule key. Let me find it. MuleSoft key is one moment. I forgot our secure key. Okay, maybe it can be here under the employees API. Right. Okay. Now it works. So I found that key. Luckily. Okay, let's put it in here. So that way we add the secret. So now it's available and can be used within our workflow. And how do we actually get it is okay. We need to get it like that, define it like that. So it goes under the secrets and mule key. And the other very crucial thing is that to run MUnits in other different environments, we need to download the dependencies for the MUnits to be able to create embedded runtime to run MUnit tests. And for that, we usually need to have an access credentials. It's a private MuleSoft repository. And we will be passing these credentials by settings.xml file. So how could we make it? We need just to, again, under the root folder, create the folder. Under the root folder, create the folder Maven, and then file settings.xml. And the same settings.xml file you have under your M2 folder on your local machine. You need to place all the servers. It will be communicated from the pipeline with to this settings.xml file. I already have everything pre-built, so I will just paste. So here I created, in my settings.xml, I have two servers. The first server is to download dependencies from Exchange. I created connected app for that. And the second server is actually our private MuleSoft repo from where we can download dependencies. Like, again, it can be Java dependencies or unit dependencies. But we obviously need them. Without them, our pipeline won't work. And as you may saw on the secrets tab, I already created the secrets for these variables. So we are good to go. But to pass them to our workflow, we need to define them within our workflow file as well. And in variables, we can define on different type of levels. We can define them on the like global level of the workflow. In here, we can define and put all the variables, and they will be visible within all the jobs and steps of our workflow file. We can also add our variables as part of the job. And it'll be visible for all the steps, and we can also add variables as part of the step, so it'll be visible only for that step, not for all other steps. Let's add that environment variables on the job level. It'll be all of this one. I will just copy them to not waste a lot of time by printing. And so as we already have everything in place and we have our variables, we just need to also define that we will be using our settings.file, setting.xml file, and we need to go with Maven. Settings.xml. So yeah, we are good to go. This step is ready. And the next step is the build the jar file. Build the jar. So we will be building our jar for the deployment. And the same way, we need to execute run command, maven package, and same things, secure key and settings.xml file. Okay. And also we may want to skip tests as we run them on the previous step. And the last step will be deploy to Cloud Hub. This is probably the hardest and the more complex step. For that step, we also, to execute that step, we need to, first of all, update our pom.xml file. We need to add here under the Maven, MuleMaven plugin, Cloud Hub deployment configuration. And I'll be doing that. Our Cloud Hub deployment tag has everything we might need to deploy application API to the Cloud Hub. We will be using connected app to deploy application to the Cloud Hub. And all of these, as you may see, properties, they defined as the properties as well. values as the properties without the values. So to make them get the values when we run, and to replace them with the values, we would need to pass them to our POM file, to our project from the pipeline, from the workflow. Um, and we will define for that again the environment variables, but that time they will be as part of the only the step, because we don't want these variables to be seen from other steps. There is no need for that. And here we will be having environment variables for Cloud Hub Worker, worker type, like all different type of things we would need for deployment. And then I will just, to speed up the process of creation, I will just copy and paste the run command. So what does, okay, yeah, the run should be under the environment. Okay, so what do we have with that script? First of all, we define a Mule environment variable. This we might need for our application name. As you may see, application name creates from a three-part. It's a project artifact ID, version, and environment itself. So we define it. We just with that script make it lowercase. Our deploy target, we make it lowercase. Then we already have our jar on the target folder, which created from the previous tab, build the jar. So we can just simply use it instead of building again from scratch the jar. That is why we just need to give it a name. We need to list all the jar files from the target folder and get the first one. And then in our deploy command, we will just provide the artifact name, and it will get the jar and deploys to Cloud Hub. So that's all we have. So we just now need to save everything and commit these changes. Commit, add workflow file, and we will be pushing our code to the GitHub. Cool. Now we need to navigate to the repository, to the Actions tab. And here now we see the MuleSoft pipeline. And we see that the MuleSoft pipeline will be executed from the MuleSoft CI/CD.yaml file. And here we may choose under the run workflow, as we need to trigger the workflow manually. We can use any branch we want, for example, to trigger. If different developers work under the different branches, they can choose their branch. And the deployment target, for now, it's just a sandbox, so we will be using that target. Let's run the workflow and see how will it be executed. Build and deploy job. We can open it. And we see all the steps we created. So first step, get the code already completed. Then when we set up Java, as you may see, it installed the Java for us to the runner, and also it cached all the dependencies needed to run MuleSoft API. Now, the random unit test is executing. It's in progress. All right, cool. So it created for us the report in the console. Probably you might need in the real scenario upload the report somewhere to the remote repository or to the GitHub. For that, you may need to update your pom.xml file in that section where the unit Maven plugin is. So the format, now we have in the pom.xml file only console. So it's printed, the results is printed to the console, but you may have it, keep it as HTML or JSON and upload this report and unit to file to any repo, to any places client may require. So then build jar, it's executed successfully as well. Cool. And then deploy to Cloud Hub. Okay, so it's deploying. And as you may see, it gave us that name we want, artifact, version, and the environment name. So let's go to the endpoint platform. And we may see here already API deployed and it created and is deploying. You may check the logs. And yeah, we can just wait when it will be completed to deploy. And then we can test it as well. So for that, what I found and what I would want to tell about is that yesterday I realized that there is sort of a defect with the runtime we are using. So when it's deploying for the first time, and it's actually, yeah, a little odd, but when we define an app runtime as 4.7.1, for the first time it deploys it successfully with no issues. But then when we deploy it for the second time, it may go to failure, saying that the runtime version is something like is not is wrong. So you may need to update that app version to the 4.7 eJava 8. Same issue I found on my project with runtime 4.6, but for the 4.6 to be able to successfully deploy API through the workflow file to the pom.file for the 4.6, you need to use values instead of 4.6 eJava, it should go like 4.6 Java 8. So yeah, that's the defect you need to keep in mind, because yeah, you may like obviously wondering why if everything is okay and the version is fine, just for you to know. So the application is successfully deployed, and now we can try to send a request. Oh, for some reason I cannot move my Postman to that screen, because I don't know, maybe it's because I'm sharing it or what's happening. Let me try a different way. Right, let me just send the request and we will confirm it, and the way you will see the logs. Oops, sorry. Go to settings. We need to get the URL, and we would send request. Okay, no logs. How could I? Let me maybe quickly. Oops. Oh yeah, now you can see the logs. And now we get an employee with ID 4. Cool. So everything works, and the pipeline is deployed successfully. Now, to wrap up everything we've just talking about, let's talk about benefits of integrating MuleSoft with the GitHub Actions. And the benefits, I would say, is these 6 benefits I found, at least for myself, very useful and easily to integrate with MuleSoft. So first of all, it's GitHub Actions has the automated CI/CD pipeline. Integrating GitHub Actions with MuleSoft, as we saw, is kind of easy. It has very syntax has a catchy manner, so you can easily learn it and use to automate all the processes of your project. This automation ensures that our deployments are consistent, reliable, which saves time and minimize errors. With that, we can get the rapid feedback, of course. So it's not just about the feedback, how we run our pipeline, our workflow, and see the logs on the Actions tab. We can add additional steps like to send a notification to Slack, to mail, to any other sources, what is actually also very good. GitHub Actions has an extensive marketplace. As we saw, it has a wide variety of pre-built actions we can use to create our workflow again with ease. And obviously, it's an ease of use of GitHub Actions, intuitive YAML syntax, and a familiar GitHub interface. Security, GitHub built-in security features with different type of secret management, which help protect our workflow. So all the sensitive information, it can be stored securely. And also enhanced collaboration. GitHub Actions enhances collaboration among team members by integrating code reviews, pull requests, issue tracking directly within the GitHub. So by leveraging GitHub Actions with MuleSoft, we can boost obviously our efficiency, enhance security, and foster collaboration within our development team. And with all of that, thank you for your attention, and I hope now you feel fully equipped to start your journey with GitHub Actions if any of your projects require it.
Yeah, I hope we are ready to take some questions. So maybe I think we have few questions already posted on our chat box.
Let me check. In what way CI/CD different from DevOps process? So CI/CD is actually part of DevOps process, but DevOps process is kind of the approach. As for me, like is a type of like as developers, we have a developer and we have a QA. That way, we have a DevOps team which creates pipelines for us, but not only, it also maintains And probably the DevOps process is not only about CI/CD, because CI/CD is attached to the life cycle of the API of the project, but DevOps is also good to set up the environment. Like I told, within our pipeline, we can create different type of self-hosted environments. So for that, we would need to have a self-hosted environment, let's say on AWS, and we probably might need to create Docker files for that and pre-build them to run, to be executed from our pipeline. And all of that, it's like a huge process, DevOps process. And CI/CD is just part of it. Oh, yeah, I see, Shubham, you already explained collaboration. Yeah, it also, is a part of DevOps. Yeah. If workflow has multiple jobs, either it takes multiple runners or one runner. No, it just takes one runner at a time. So the runner is an environment for the entire workflow, and not only for the job. We just define it under the jobs section. So our all entire multiple jobs can be executed against and on that environment. But we can only have one runner for the workflow. Any GitHub plugin required in Visual Studio to write the workflows? No plugins, you don't need any. Hi, we will take the question shortly. Can we make generic steps in GitHub Action for certain categories of repositories, or should we configure steps for each repo individually? Yeah, so we can create a repository with a pre-built steps, with pre-built jobs we want to execute, and then we can reuse and refer to this file from other repositories within our organization. So obviously, but we anyway can create the workflow file for each of our repo. We just need from that file refer to another workflow file logic. Developers' KPIs are based on changes in their paid based on velocity. Moments while operations KPIs based on stability. It's not. It was okay. This way develops. GitHub Actions and MuleSoft Cloud Hub are two different. GitHub Actions and MuleSoft Cloud Hub are two different entities. So how they have interact to each other for doing CI/CD on Cloud Hub with help of GitHub Actions. Sorry. So basically, like here during our demo, I just show you the piece of thing we can do with the GitHub action, and it was the build and deploy of an API. But we can also create a workflow, for example, which can send a request to our API to check it on readiness and health. We may also create a workflow which will do a rollback. And of course, also we can use our, within our workflow, we can use Anypoint CLI as well, which provides us a lot of opportunities actually to interact with Cloud Hub. So it's just depends on the tool and CLI or actions you use within your workflow, but here you don't have any limits on the steps. Okay, regarding if I want to deploy to RTF instead of Cloud Hub, what changes? So if you want to deploy to RTF instead of Cloud Hub, the only thing that changes is probably in here the pom.xml configuration. Other than that, and probably if you have an RTF, you want to keep your code secure. So probably for that, you might need to create also a self-hosted runner. But if we're just talking about what we did today and comparing to RTF, it's just changes in pom.xml configuration. We'll maybe have a plugin. So there is no IntelliSense to write actions in Visual Studio, like correcting indentation, sensing keywords, etc. Well, I cannot. I didn't know. I didn't even. Yeah, I didn't know if it's present. To be honest, we might check. But as you may saw it anyway, highlight when I created and write in the file, it highlights me different type of thing. Like it was initially with this rate highlights. It's saying create jobs, and it's when I started to type secret, it also provides me different prompts. So yeah, that would be checked, to be honest, because I usually create them manually from the Visual Studio without using any tools. But yeah, if we have one, we need to check for that. I presume in your presentation there is no relationship between GitHub Sandbox and Anypoint Environment Sandbox, or the choice of sandbox name as a target related to Anypoint. Yes, it is related to Anypoint environment name. Because when we deploy to Cloud Hub, we need to provide an environment to which we want to deploy our API, and for that, it's just to make our workflow reusable. As I told, we pass that option to the deploy. Let me show you quickly. We pass that property to our deploy configuration, because for the deploy Cloud Hub deployment configuration, we might need that environment. And to make it work with different type of environments, we just pass it over to our project from the workflow by defining that deploy target. So this is our Cloud Hub environment, and we get value for it from deploy target. And that deploy target comes from the input. So that means that if you have in the real life scenario environments like prod and like QA, so depends on the option you will be using, it'll deploys your API to that environment. And that's just about reusability and flexibility. I think it was the last question. Any other questions? Deploy phase. Can you please explain deploy phase? What do you want me exactly to explain? You may unmute yourself.
Yeah, am I audible, Selena?
Yes.
Yeah, thank you for making me call out. So this deploy phase, right? You take the artifact and deploying, right? So can we place upload locally this artifact? For example, if I wanted to see the size of the file, for example, right? So can I download that artifact from Git hosted runner to my mission? Also, could you please explain those arguments, what you are trying to face, pass? So this is my question.
So you may want me to tell you what's the properties mule artifact, secure key, and all of them means, or mm, sorry, I didn't get.
Yeah. So the arguments you are passing, right? Connected app ID, secret, environment, region, right?
Yeah.
So you have applied some regular expression, SCAD, right? So line number 48.
So um, is your question is about why do we define an environment variables within that step?
No, line number 48 tells, regular expression, isn't it?
48.
So
Oh,
SCAD hyphen E, right? I mean,
yeah,
what we are trying to do, are we trying to print something for the user's perspective?
yeah. I see what you mean. Yeah, sure. So um, what we are trying to do with that line, here we just define mule env variable, um, and we do it by just this is the command to update our Cloud Hub environment, which is deploy target, to be lowercase. So we want that part to be uh, in our application name, mule environment. So we pass that property mule environment to define that last part of application name. And as we pass our deploy target as sandbox, sandbox, sandbox has the first letter um, uppercase, so we might want to have all of the letters lowercase, and for that we need that command to run. So it's just a Unix library set, which functioning and doing all the job for us, and update the Cloud Hub environment, our deploy target, to be lowercase. Here is an artifact name. We need that artifact name to be able to deploy our jar file to the Cloud Hub. And we might need in our Maven command provide that artifact name. Here we are passing the artifact we want to deploy to the Cloud Hub with that property. And artifact name is just the name of our jar file. So we just list all the jar files in our target folder. Target folder is the one which was created during the build the jar and build the API step. And we just get the name of that jar, and the head -1 means we don't need if any other, but obviously we will just have an only one jar file. We just get the first line of that listing and assign it to the name of our artifact. So then it goes directly to and get that artifact jar and deploy to the Cloud Hub. So that's the way. That's how it works. I hope I did answer to your question. Let me know if not. Thank you. Yeah, thank you too.
I think this is good. There is no more question, and so let me stop the recording.